Merhaba değerli katılımcılar, hepiniz hoş geldiniz. Şu an sesimde bir problem yok herhalde. Saatte 8 geçiyor. Dilerseniz başlayabiliriz. Bir onay alabilir miyim Medibox tarafından?
Tabii ki hocam başlayabilirsiniz.
Tamamdır. Değerli katılımcılar, hepiniz tekrardan hoş geldiniz. 2022 yılının 3. webinarı, TÜYAK webinarına hoş geldiniz tekrardan. Bugünkü konumuz yangından korunma ve patlamadan korunma arasındaki ilişki ve bunun fiziksel ve regülasyon olarak değerlendirilmesi. Bugün aramızda Profesör Uwe Günther Klasmayer var konuşmacı olarak. Tekrardan başlamadan önce kendisine bizi kırmayıp katıldığı için ve bilgisini bizlerle paylaştığı için teşekkür ediyorum. Kendisini tanıtmadan önce derneğimizin TÜYAK Yangından Korunma Derneği ve Vakfı adına birkaç tane duyuru yapmak istiyorum size. Öncelikle binaların yangından korunması hakkındaki yönetmelik kitabı basımı önümüzdeki günlerde bitmiş olacak. Yeni kitabı TÜYAK ofisinden temin edebilirsiniz ya da mail yoluyla isteğinizi iletebilirsiniz. Basılı bir şekilde binaların yangından korunması hakkındaki yönetmeliği edinebilirsiniz. İkinci olarak TÜYAK Yangın Mühendisliği dergisi sayılarımızı yayınlamaya devam ediyoruz. En son Profesör Doktor Abdurrahman Kılıç için hazırlanan basımı gerçekleştirilmiş özel sayı, bu sayı çıktı. Yine bunu TÜYAK ofisten bedelsiz olarak temin edebilirsiniz. Yine aynı şekilde tuyak.org.tr'den web sitesinden web halini de okuyabilir, indirebilirsiniz. Üçüncü duyuru TÜYAK Sempozyumu ile ilgili. Biliyorsunuz TÜYAK Sempozyumu 2021'de yapılması planlanıyordu. Ancak Covid sebebiyle 2022'de yapılacak. 31 Mart 2 Nisan arasında İstanbul Lütfü Kırdar Kongre Merkezi'nde Rumeli Sergi Salonu'nda gerçekleşecek. Uluslararası Yangın ve Güvenlik Sempozyumu ve Yangın Güvenliği sergisi bu yıl yangın mühendisliğinde tasarım, uygulama ve işletme temasında gerçekleştirilecek. Bu yıl 7.sini gerçekleştiriyoruz. Sempozyumda sunumların dinlenmesiyle birlikte sergi alanı da aynı zamanda gezilecektir. Ve daha önce 2 gün olarak yapılan sempozyumumuzu ve sergimizi bu yıl 3 gün olacak şekilde planladık ve hafta sonu da dahil olmuş oldu bu plana. 31 Mart 2 Nisan arasında. Online kaydımız açılmıştır sempozyumun. Yine tuyak2021.com'dan online olarak kayıt yaptırabilirsiniz. Ve aynı zamanda bu sempozyumun mobil uygulamasını da en yakın zamanda yine ilgili web sitesinden ve sempozyuma kayıt yaptırdığınız zaman mobil cihazlarınıza indirebilir. Oradan programı ve tüm detaylara, işte lokasyon vesaire gibi detaylara o uygulamadan da erişebilirsiniz. Aynı zamanda sempozyumda 3 adet kurs düzenlenecektir. 31 Mart'ta davlumbaz söndürme sistemleri tasarımı, bakım ve uygulama örnekleri kursumuz eğitmenler Deniz Atik ve Alican Kabataş tarafından verilecektir. Tüm günlük eğitimler, bu eğitimler. 1 Nisan'da mimari tasarımda yangın güvenliği yine eğitmen Doktor Gökhan Balık tarafından verilecektir ve 2 Nisan'da NFPA 13'e göre otomatik sprinkler sistemleri tasarımı temel eğitimi eğitmen Bora Kocaman tarafından verilecektir. Bu eğitimlere de yine bu TÜYAK 2021 sempozyum sitesinden ve TÜYAK'la iletişime geçerek kayıt olabilirsiniz. Biraz TÜYAK'la başlamış olduk. Ben tekrardan Sayın Profesör Uwe Günther Klasmayer'e teşekkürlerimi iletiyorum. Hem derneğimiz, vakfımız adına. Ve kısaca kendisini tanıtmak isterim. Uwe Günther Klasmayer 1952 yılında Almanya'da doğdu. Proses mühendisliği lisans ve yüksek lisansına sahip ve aynı zamanda Proses Teknolojileri Enstitüsü'nden doktora derecesine sahiptir kendisi. PTB Research Araştırma Enstitüsü'nde patlamaya dayanımlı elektrik ekipmanları üzerine akademik çalışmalar yapmıştır. Aynı zamanda son olarak da Normatik'de ATEX ve IEC müdürü olarak çalışmaktadır. Danışmanlık hizmeti vermektedir. Ben böyle kısaca bahsedeyim. Aynı zamanda tabii simültane tercümemiz olacaktır bu webinarımızda. Alt bölümdeki tercüme kısmından dinlemek istediğiniz dili İngilizce ya da Türkçe olarak seçebilirsiniz. Aynı zamanda orijinal sesi kapat dediğinizde de arkadan gelecek orijinal sesi kapatarak sadece tercümeyi duyabilirsiniz. Ben tekrardan sizlere vakit ayırıp katıldığınız için teşekkür ediyorum. Yaklaşık 1,5 saat sürecektir webinarımız. 1 saat civarında sunum ve son yarım saatte de soru cevaplarınızda ben tekrardan sizlerin sorularını Profesör Uwe Klasmayer'e iletmek için tekrardan bağlanacağım. Şimdiden hepinize iyi seyirler. Umarım faydalı ve güzel bir webinar gerçekleştirmiş oluruz. Buyurun Profesör.
Çok teşekkür ederim Tolga Bey for the introduction. Türkçe konuşuyorum. Kolay sohbet tamam ama zor sohbet mümkün değil. Maalesef. So my presentation today is in English language. I think we have a very good interpreter, and so at the same time you can listen to the Turkish version of my presentation. All slides are in English, so you have to listen my explanations, which gets interpreted by Şebnem Hanım. So let's have a start. And so I want to give my screen free. And what you can see here is what you may not expect, the strong relation between fire protection and explosion protection. The idea last year in Izmir at the big conference, there was the idea to say, let's have a look also in explosion protection, because this could be a nice opportunity to compare or to see the interlocution between fire protection and explosion protection. What we are talking about are risks which are very huge. You can see a fire risk, a fire hazard, and an explosion hazard is extremely strong. So we have to take care in the planning of a factory, the design of the factory, the components you can all find in the factory. We have to take lots of time for it. So if you need more information, you can go to my email address. You have my email address, you have my phone number. And if you don't mind, please use English language. So that would be great. I am working with my colleagues at Normatik, Mühendislik Test Gözetim Belgelendirme Limited şirketi in Istanbul. And our colleagues together, we are covering the whole field of industry. So electrical inspection, training in ATEX, then certification assistance, whatever you need, we can make from Normatik, and I'm responsible for the ATEX ICX field. Okay, let's have a look in the structure of the presentation. We want to see that it is possible to cover the risk assessment for fire and explosion hazards in one procedure. That is only a short slide of it. Then we have the comprehensive concept for explosion protection. This is really very important and the highlight of this presentation. I just want to explain how it works in explosion protection so you can see how the concept in explosion protection is working. And it's working very successful because all the accidents, what you can see in television or in the media, you will see they infringe the rules which we have laid down in the concept. So third, we have the physically based protection concepts to avoid ignition sources. It means that we have certain technologies which are helping us to avoid an ignition. And then fourth, we have to make a documentation as an owner or operator of such a factory with X hazards. And then we want to step in more detailed in the safety concepts of type of protection for equipment. And these so-called types of protection, I want to explain to you how this is made and how to test the equipment and how to make sure that there is no ignition risk in your factory. Yeah, and finally, we have questions and answers. So the presentation will take 45 minutes, and then we go over to the questions and answers. Okay, first of all, I want to show you a nice example. And I will go to YouTube now so that you can see here a nice example how it's happening in practice. And this is a situation everybody knows. You are going to the gas station and this person is printing some, maybe her credit card or something like that. And then she's opening the tank of her car. Then she takes the nozzle, starting the pump, and then finally refilling, putting the nozzle in the tank. And because this takes some time, starting the pump, she is sitting in the car and maybe looking at her WhatsApps and making something to deal with her mobile phone, having a phone call. And you can see her cloth is maybe from synthetic material. And now she's touching the nozzle, and then you can see it's an electrostatic charge on her body. And this is in sending the cloud, which comes out from the tank. So this is, I think, a nice example what we can take as a start. Come back to my presentation. And therefore, you can also see here in this structured approach to identify and eliminate hazards, which helps you to operate such an explosion risk assessment, fire explosion risk assessment. In any case, for fire protection and for explosion protection, we have to deal with electrostatic discharges and sparks. And therefore, the synthetic clothing, which you could see from the person refilling her tank, yeah, this is a typical situation and one of the most popular and most seen ignition sources, what you can find making a disaster sometimes in the factory. Then this could happen by moving liquids, moving powders, friction from moving parts of machinery, and so on. And so you have lots of...
All right. Welcome to this live stream of Engineering Trainer TV. My name is Luc Hennen. I'm the CEO and founder at engineeringtrainer.com.
Oh,
and today we're all going to have a conversation with Juan Manuel Mendez Franco. He's the CEO.
Sorry, this came from YouTube. I didn't stop it correctly. And this, this helps you also to take control on the electrical and mechanical equipment, which you can find here, from the motors, control panels, lighting, and so on. All these elements and these components are potential ignition risks. As you can see here, the relation between fire and explosion, as you have seen, the person who she refilled her tank, then the nozzle was still burning. And there you can see, as soon as there is some benzene, some gas spitting on the ground, you can see, then we have the fire. Then the fire will start. And so the explosion is first, and then the fire will come. And this we have to always to take in mind and to keep in mind as soon as we are making such simulations, what can happen, and when you conduct your risk assessments of the factory. Okay, then you can see here also the other way around. So what we have here is a fire. So the fire starts, and at the end of the day, we have the explosions from the hydrocarbons. And so a high pressure process reactor has cracked. And steel, because of there was corrosion or something like that, steel material failed. This caused the release of hydrocarbons. The hydrocarbons, they get mixed with air and caused a detonation. The spilling liquid hydrocarbons get ignited and then finally cause this really very, very big fire. Okay, coming to the comprehensive concept of the X system. And this is to show you that let's start with the equipment which has to be designed and which are the components you can find in such a factory, lighting, motors, and so on. They have to be designed according to IEC standards. The IEC standards, this is the source. As soon as you see, okay, this is IEC, I have to apply a European norm, then you have to be aware that the European norm is identical to the IEC norm. The IEC standard is under control of so-called maintenance teams in the IEC level. And responsible for this is the IEC Technical Committee 31. And we have in Turkey, we have a mirror committee for this. This is the TSA MTC 113. So as soon as you join our national committee, I'm also a member in the national committee. As soon as you join this committee, you will get informed about all standardization activity which you can find on IEC level. The AN standards, which are basis of the presumption of conformity for the European Union directives, they are identical and they just copy and paste the text from the IEC standard. The whole maintenance is made of the standards is made on IEC level. That means we have one standard for the whole world. Wherever you go and you come in touch with explosion protection, you have to follow the specifications of the IEC standard. This is a big step ahead. And this means that one level for the whole world is given, one safety level for the equipment, for factories dealing with explosion risks and so on. Everything is covered by IEC standards, and everybody has to make use of these standards because you can find this in the regulations worldwide. We have in the European Union, we have the regulations which are called European directives. Turkey has taken over the Users Directive 1999-92 and also the Manufacturing and Equipment Directive, the Free Trade Directive 2014-34. So what we have to look at now is, okay, we have equipment which is designed and produced, and this is very important. The CE declaration means also that there is you can know about the modules. The modules are made under production surveillance of a notified body. Means not only the design is made according to the IEC standards, also the production is made according to the standard requirement of this part 34. Okay, everything, when you start to design a factory, then you have to make a risk assessment, fire risk assessment, explosion risk assessment. This is made under the IEC standard part 10. Here is to see 79-10-1 for gas. I'm sorry, this is missing here, the name of the standard. Ah, here. Okay, I'm sorry. I have here. You can see it here. So this risk assessment is leading to a zone classification. This zone classification makes three classes of risks. A very, very high risk is to find in a tank. A slightly lower risk you find around the tank. And a lower risk you can find a little bit far away from this tank. Means you have zone 0, zone 1, and zone 2 to classify before you start to construct such a facility. So everything starts with this zone classification according to 79-10. Finally, you have to install some equipment, motors, lighting, and so on. All those equipment components have to be installed according to 79-40. Means, first of all, you have to select the right equipment by saying, okay, zone 0 inside the tank has a very high level of safety. This equipment is equipment protection level 1. So then you have to be aware that here around the ventilation opening here of the tank, there is a zone 1. Means you need to install equipment which is made according to EPL2, equipment protection level 2. And for zone 2, you need equipment protection level 3. This is all to find in the related standards, which you can see here for the marking. So when you have installed everything, then you have you can operate such an factory, but finally you have to make inspection and maintenance, and this is made according to part 17 from the standard group. Then finally you have to repair everything if there is a need to repair, and therefore we have the 79-90 IEC standard, and there you can see a guidance, and the requirements, how to repair equipment and to reinstall or to say, okay, we need a new one. So as you may see here, the whole life cycle is covered by IEC standards. And this is a very big advantage we have in explosion protection. Again, here, this example, you have a tank and there is a liquid, a combustible liquid. Here you have over the liquid, you have the zone 0 situation. And so everything what you have to buy here as an equipment, level gauge or whatever, a level gauge has to be equipment protection level 1. But we come later to it. Don't be confused. We will detail all these wordings later by examples. Okay, so as I said already, and you have seen in the YouTube example, and this small accident we have witnessed there, it is very common to have ignition sources which are electrostatic charge. And electrostatic charge is always to prohibit by earthing, bonding, earthing. What you need is always, when you have to operate such a factory, be aware this electrostatic charge will meet you at any situation. As you can see, as soon as the worker is have such a sack here and is emptying it, then you have a flow of particles coming down here, which is causing electrostatic charge. Unfortunately, you also have a cloud of particles, of dust particles here, and these dust particles are forming a combustible atmosphere in mixture with air. So this is a big ignition hazard which can be ignited partly very easy. Also here, this pipe is causing electrostatic charge because we have a liquid, maybe a not conductive liquid, going here through the pipe, and then the wall from the pipe will get loaded by electrostatic charge also. And you can imagine, as soon as this is a plastic material, then the charge will be very big because earthing is not possible by insulating plastic material. Insofar, it's better to have a metallic pipe here. Also the shoes. So your body is, you can feel it as soon as you go over a carpet and then you touch a door, and then you will see that you get an electric shock. And this small electric shock, which you can find because your shoes are insulated, this is another hazard which is very, very common. And therefore, always using in chemical factories, you have to use shoes, special shoes, which are conductive, which have a conductive sole. So here have to be, this is a plastic material, and you have to embed here some conductive powder, and to make this conductive and to prohibit that you have a charge on your body, this has to be discharged always over the ground directly. Here is another example where you can see, okay, this system is also charging some electrostatic charge. Here is another example if it's plastics, and also here. So this is the most common electrostatic charge. The situation, what you can see here, is also very common and very normal, not only in big industries, but also in small and medium enterprises. So also in small and medium enterprises, you have a storage tank. And you have here some barrels. And the barrels maybe are not sealed totally, means that some leakage is spilling on the ground or gets evaporated directly in the ambience, which is air. To avoid an ignition here, you have to make a ventilation. This is what you have to consider as a first approach always. Always, as soon as you have a certain amount of combustible material mixed in air, then you have to make a ventilation. And the ventilation is, in this case, here you can see the fan, and the fan is pushing out this gas mixture directly to the ambience. And therefore also you need here a gas sensor, and you have to know about the material which you are storing here. Some materials, these are two classes, some materials are lighter than air and some materials are heavier than air. And as soon as they get evaporated. Usually solvents are heavier than air, so you have here the situation that it is an ignitable atmosphere here. So as soon as you're coming with your boots here, which are not conductive, then you can see this can be ignited only by walking. And that's a big hazard we have to be aware about. Okay, we have another typical situation. We have gas bottles with air heavier than air. And these gas bottles are stored here in this room. And then you can see how the invisible air gas mixture goes here in the sink. And this is extremely dangerous because the sink is a channel system. And as soon as you ignite here by your boots here in this area, then the whole channel system will get exploded. And then you have the result that your whole factory gets blown up from the ground. And this is a big hazard. This has to be avoided. And therefore, be aware about such a situation where you need something to do against. And what you can do is you have to measure the gas concentration, because we are happy to have a lower explosion limit and we have an upper explosion limit. Means we have an explosion range. And as soon as the instrument will measure that we are inside this explosion range, then there has to be an alarm. As soon as we are under the lower limit, then it's not ignitable. As soon as we are over the upper explosion limit, then also it's not ignitable. Then, yeah, we have to make the maintenance, which is necessary. As soon as you have here a distribution system, you have to maintain it. You have to sign such areas and such rooms. You have to make for the workers, you need operation instructions, and especially for the distribution system, you need also instruction for the using personnel. Yeah, then we have the leakage of combustible gas or liquids in mixture of air, again by such storage systems, tank systems. Then as soon as the system is a little bit older, it could happen that the flange sealing system gets unsealed, and then you have a leakage here. And this is what we have to consider also in our risk assessment according to part 10 of our standard group, the so-called zone classification. We have to consider that this may happen. It's not very likely. So then you have to say, okay, I can avoid this situation by having inspection, and I have an instrument frequently measuring the leakage, a potential leakage, and I go through my pipe system and I try to find such situations. And so this is how you can avoid the leakage of unsealed flanks. Also, you have combustible particles in mixture with air, and this is to find very often in a factory also. Yeah, this is another example. Here, it's unavoidable. As soon as you are painting a big surface and there is a solvent inside, you have to be aware that this solvent is evaporating, and that you have to be very, very careful in dealing with this procedure. And also you can see that such leakage can be detected by such devices. And sometimes you have a corrosion in a pipe, and that what we have here as an example also is from a gas station. So here you can see a gas station. A car is refilling the tank, and what we are doing is we are pumping liquid from the tank truck here in the tank. Usually here is the ventilation opening. The ventilation opening will dilute this vapor in the air, directly in the air, and cause an explosive hazard. But here you can see this will be directly led to the tank, because the tank gets empty, this tank gets full, and we can be sure that this volume comes directly back to the truck. Means this is at the end of the refilling of this tank, is this tank full of gas, which comes from this tank here. Yeah, that means that we have avoided an ignition risk and explosion hazard very easy. It's not very complex. Same for the car. You can have also two pipes here. And one pipe is the liquid, and the other pipe, the air comes out here and back to the tank. And that means this, what we have seen in the YouTube video, this was caused by the fact that the air which comes out from the tank has been incendied by the ignition spark, comes from the electrostatic charge of the person. So this can be avoided by having such a technology. Not very complex, but very, very interesting to avoid explosion hazards. Here you can see the design. Okay, what we are talking, coming now to the basics, is explosion protection. Means we have to be aware that what we need for such an explosion hazard, or what we have to avoid, is the oxygen on one side. How we can avoid oxygen? By inertization, nitrogen, for instance. So we have an ignition source. We have to eliminate this ignition source. And finally, we can combustibles avoid by combustible gas-air mixtures. We can avoid by ventilation. Also, you can see that sometimes solvents are the combustible materials, and the solvents can be replaced. And so when you see some example, the paint you can use at home, coming from Home Depot, and you are taking this paint home, and you will see there are water solvents inside. So only water they are using to make this paint liquid. Solvents are not really often to find, because the solvents make the explosion hazard also for you at home, which can be avoided by using water as solvent. Coming back now to the explosion range, some physical basics we have to take care about now, and we have to say, okay, sometimes a mixture is too lean and you cannot cause a combustion. A combustion is not possible in this case. And so you have eliminated your explosion risk. This can be done by ventilation. So as soon as you are coming here to the explosion range in the concentration, then you have a lower explosion limit and a higher explosion limit. Over the higher explosion limit, you can find that the mixture with air gets too rich and a deflagration and no explosion is possible. So then you also have solved your problem. The only what we have to avoid is this explosion range of a gas or vapor air mixture. How to make it? This is only to introduce you in certain markings. And I have to say the marking for explosion protected equipment, which is sure that we have not an ignition source in our factory, means we have a type of protection used, which is laid down in an IEC standard. These design requirements, there we have a certain marking, and for flame-proof enclosures, maybe you have seen already, you have the flame-proof D, and you have a protection by enclosure against dust, and it's T. And it's a jungle of markings. And I never will go through here because it's too detailed. Maybe if we have time, we can come later to it. But this is only to show you that a certain marking of equipment makes it easier for the maintenance and inspection and repair. And therefore, we have this detailed marking available. So let's have just one example, an experimental test for an XD motor to ensure the safety of the equipment. You have to see that such a big motor, sometimes it's more than 3 tons, 4 tons, big drives you can find in a factory for big pumps and so on. And so this motor as a type, as a prototype, gets tested, very complex, is submitted to very complex tests. Means what we are doing is we are creating a simulation of their installation location. So, okay, we take the motor, we have, for instance, a vessel or a foil around the motor. And what we purge here in and what we bring in, inside the motor, we will have explosive gas like hydrogen air or propane air, whatever the risk class of this motor is tested for. And the highest risk class is as soon as you bring hydrogen air here in this system. And so after we have made the best and most hazardous concentration of hydrogen and air, which is 28%, 38% around this hydrogen in air, then we simply make an ignition inside the motor. Inside this enclosure, you can see then an explosion. And this explosion makes a big bang, but only inside, if the motor is safe and the design is safe. If the explosion gets and the related flame gets here through the small gaps to the outer area, then you will see that the whole gas amount will explode. And then we have to make sure that the design of this motor has to be changed, and the gaps which are necessary here for between rotor and stator, and the stator here, that this has to be made more narrow. Everything is put down in the IEC standard. All details, what you can find in the IEC standard. So you, as soon as you read the standard, you immediately know what you have to do for such a test. When you see a forklift in a zone, you may ask, how is this possible? Such a complex equipment, how to make sure that there is no ignition here, source here from the wheels to the ground, and there is a big motor inside the engine, and this could be a diesel motor, it could be an big electrical motor. You have, for electrical forklifts, you have a big battery inside, lots of power you can find inside of such an equipment. And there you can see how this is done. It's simply, you are going from component to component and make a risk analysis. And so here the seat, as soon as you see here a plastic seat, you will see, oops, plastic, you have electrostatic charge again. As soon as the person is sitting here and leaving his position and stepping to the ground, then you have to make sure that this movement is not causing electrostatic charge on the person, and which is discharging on the ground and then causing a discharge, which could be an ignition source. Same here. As soon as you go to this element, then you can see he is always manipulating here. And so this also can cause electrostatic charge. Then you can see here the moving part from the fork and to this element here. It's moving slowly or quickly, and you have to be sure that the combination of this metallic material and this metallic material, inclusive the forks, does not cause sparks and arcs. So this is possible only to show you, as soon as you go through how many potential ignition sources you can find, it's a long, long list. And therefore, you can imagine, as soon as you have a normal forklift here, a normal forklift never will be suitable and allowed to use in explosive atmospheres of especially zone 1. For zone 2, there are some design elements are less complex, but also you cannot use a normal forklift in zone 2. Now we are coming to the marking of ATEX products. This is what I said. The CE, everybody knows the CE. And we have here the epsilon X marking. This is also necessary. This is a mark which comes from the European Directive 2014-34. And then we have this complex marking, group 2, category 2, gas and dust. So this is so complex, you need a little bit more time to understand it, and you cannot find in the directive itself there, we have some guidance made by an ATEX guide, and then you can see that this could be more helpful for you for daily use. Yeah, we have to say, we have 2 directives in the ATEX system. This is the European Directive 2014-34. This is the trade directive. This directive only takes care about the equipment to be used in explosive atmospheres, only for the equipment. This directive, 1990, 992. This is the risk assessment directive. And here, this you have to take on board before you are planning a facility with explosive hazards inside. And here you have to apply for the zone classification, the part 79-10 and -1 for the gas and part 2 for the dust explosion risks. And this means after you have made this exercise with these standards, which is really also very complex to conduct, means you have to make calculations, you have to assume leakage situations, you have to assume ventilation in your location, which could be in the mountains or at the coast. So wherever it is, you need to assume which ventilation you can assume, and so on, and so on, and so on. Many parameters you have to put in the calculation so that you finally can say, this is zone 0, this is zone 1, and this is zone 2. And then finally, we have the selection requirement here. It's only permitted to use CE declared equipment. And this has to be marked with this hexagon X coming from this directive. Okay, so this is a history for the so-called trade directive. And the trade directive has, maybe you have been confronted with this also with this number, 94-9 EC. This old directive has been replaced in 2016 by this new directive. But all equipment, what you have bought maybe some years ago, which is made under 94-9, can also be used here in this for this the compliance with this user style. This is only to say that. Okay, now we are coming to the duties of the obligations for an employer. So as soon as you are an operator of a facility, then you have to make a documentation. And this documentation is very important. You can think about and you say, okay, I made it. So, but the inspectors who are coming to your factory will ask for a documentation, and that's correct. So whatever we are doing, we have to explain this, and not only by wording, so we have to explain it on paper. And that means that documentation needs some, this is a so-called explosion protection document. And inside this explosion protection document, so you have to explain what you are doing: preventions of and protection against explosions, assessment of explosion risks, general obligations, duty of coordination, blah, blah, blah. Everything you have to make a documentation of it. Let's go through. So the prevention of risks, you can, at the very beginning, to modify a process or a product. And this means paint without solvents based on water. This is what you can do. So then you can say, okay, I have a strong ventilation for my location, and I will thin my explosive mixture continuously under the lower explosion limit. This is what you can do. But then you have to make a calculation. Then you have to say, here is a leakage, here is a potential leakage. How is it possible that this ventilator, this equipment, causes such a flow which makes a dilution of this potential explosive atmosphere? Or you can say, okay, we have a hermetic pipe system and valves. We are only using flanks which are welded. And you can say, okay, my valves, they have no opening, no chance that material goes from inside to outside. magnetic valves sometimes, okay? So this is what you can do, and you have to explain why all these things cannot be used so that we are running definitely in explosion risks. So now we have to say assessment of the explosion risks in Article 4. We have to say how serious is this explosion risk? And we have to say, is it maybe possible to reduce the likelihood that explosive atmosphere may occur? And to use continuous processes, as an example, use continuous processes and not batch process. So we have changed our process. We have now a continuous process with absolutely closed pipe system, and we don't fill, refill, and so on, and deal with any containers, IBCs or whatever, which have to be to come from here to there. So everything goes in a closed pipe system. This could be also a measure to avoid explosive atmosphere. So we are storing the solvents in big containments and not small ones to avoid often change of empty containments and so on. So this is really a very important exercise also. You have to make clear that you have done it. Then what we have to talk about is effective continuous supervision of the places and equipment if there is explosive atmosphere. So what we have to do is the situation in a factory today, it's new. Tomorrow, it's old and it's used. And therefore, what we need definitely is a supervision in a senseful frequency. So each year, if it's a very high risk, then each month, or if it's a pump which is always broken or does not work, then you have to make it every day, or you have to make it in a way that you have a control system which is telling you that at a certain point a pump is not working. So that's the exercise you have to make here. And you cannot do it with persons who have not a training in explosion protection. You need trained experts for sure. And nobody else can make such a supervision as soon as they are not trained. And this is a big, big issue we have, that as soon as you're going from factory to factory to factory, you will see that one factory is really very progressive, and it makes training and give the opportunities for their employed people to have a very time-consuming training. Others don't use this, and therefore sometimes you find in the field people who have not the training option. And then we have to say to the management, okay, you have to do some training for your employees, because the employed people, they always are willing to do such a training, but sometimes the management don't want to pay for it. Okay, so the duty of coordination, this is also very important. Tascheron. So what you have service companies. And we have one nice example in Ludwigshafen for BASF, which is not really nice because I think 4 people died. And this means that the service company has no idea what they are doing in repairing a pipe system. They went to the pipe system, they get to know, okay, please cut the pipe here and make a new flange there, and please make a valve here. But they didn't know what's inside the pipe. And they didn't know that they have to clean the pipe system first from explosive atmospheres, from vapor, air mixture. And therefore, the whole pipe system exploded, and then you can see the result. And this is now in the duty of BASF to pay for it. They have to pay. and not the company has to pay, because BASF is responsible for this event. And this is always very important to know for factories and their management. You cannot say, oh, my Tascheron make a mistake. So this is not possible. The judge definitely will say, okay, you have the full responsibility to say, okay, I made the training. They have all knowledge which is necessary to conduct the work. Yeah, appropriate training and satisfying training level of the workers is required. Yeah, then the zone classification. I told already that it's part 1 and part 2, the training, work permit, and so on. And so I think finally we have to make a documentation, and this documentation is the so-called Patlamadan Korunma document, and means explosion protection document, explosion that have to be determined and assessed. Adequate measures will be taken to attain the aims of this directive. And those places have to be classified into zones in accordance with Annex 1 of the directive. Those places were the minimum requirements set in Annex 2, and that the workplace and work equipment warning devices are designed, operated, maintained with due regard for safety. Yeah, and that this means that in accordance with the workplace safety, the general workplace equipment safety is harmonized in this way. Okay, then we have modified with the oops, I can skip that. Okay, so you are not alone. Whenever you get confronted with such a problem, I need a zone classification. I need to make a hazard assessment, explosion hazard assessment, and you identify such a hazard. Usually you don't invent the wheel again. So what you need is the contact to companies, consultancy companies, or anybody else who has experience in the zone classification and the hazard explosion hazard assessment. But also you can read such documents which are issued by ISA. This is a European organization for workplace safety. And they have so nice practical assistance, giving so nice practical assistance by these documents. And so there you can find such examples. And as soon as you have a storage system here, there's no need to make all the design on your own. You just take from here the such an example, and you are following the description, and then you are happy. Because here you can see zone 2 is specified for the area 1 meter above the cabinet. So above the cabinet, you have to be aware that there's 1 meter zone 2, not zone 1. Inside is zone 1. And that's it. And this you have to just to take here as a source and then make your individual personal risk assessment for your factory. But that's only to say by 3 methods we may learn wisdom. First, by reflection, which is the nobles. So everything you can anticipate, everything what comes up to you, you can say, I make a simulation, and then I know what could happen, and I can identify any risk. And so everything on a theoretical approach. You can do that. And then you can see that very recent systems, simulation systems, software, indeed, you can make lots of things by assistance from these simulation software. And then you are really in a very big, in a very nice situation. Okay, then the second, by imitation, which is the easiest. So you can copy and paste. And this is also a nice option. I like it. And so copy and paste. Our Chinese colleagues, they are always loving this also. And so the third, by experience, which is the bitters. So as soon as you have an accident, and then you have made an experience, you have learned the lesson, but then you have the fatality, and you may have a very bad experience with dead workers, and this is not what we want. Okay, then I'm not sure how is the time. I think, is the time gone? Tolga?
Süremizi aslında biraz aştık. Ama dilerseniz kısaca toparlamak isterseniz bir 5 dakikada toparlayabilirsek iyi olur. Evet.
Tamam. 5 dakika daha. So we make a quick overview on the types of protection. And this is what I told you already in the test of such motors. This motor is increased safety at the terminal blocks. And here we have the flame-proof motor, and you will see such an EU type examination certificate. This is a little bit older. This is EC type examination certificate. Okay, this is a flame-proof motor with increased safety terminal boxes. And you can see the marking here is granted by the certification body. Because this equipment is to be used in zone 1, it needs a certificate. As soon as it's here, zone 2, then it's category 3, and then there's no need to make a certificate. So you can hopefully trust the manufacturer. They don't have such a certificate by an ATEX notified body. So let's go through. There you can see the IEC standard, and this is the main standard. You have always to apply the 60079-0. These are the so-called general requirements. And this you have to apply in any case. Then we have seen already the types of protection. And then this is also to decode. It's somehow how to decode all these markings. And so for group one, this is in mines. This is suitable for mines. Group 2 is, as an example, a refinery. And we have the equipment protection level GB, MB. And as soon as you see gas classification B, equipment protection level B is category 2 in European marking. Okay, so it's too much for now and too much details. And there you can see all types of protection. I just want to show you how many types of protection you can find. Lots of. And because you have to cover the whole equipment in factories with suitable elimination technologies of ignition risks. And therefore, you can find so much technologies in the IC standards. And here it's also a nice example. So this is good for group 1 in mines, EPL, GB, MB, DB, and also for group 2, EPL, GC, DC. C is group 2, zone 2 installation, means category 3. Let's go through. There's not so much time. I just want to show you this. Okay, this is the decoder. And there you can see, please here 2014-34, there is a mistake. This is a decoder between the European norm 79-0 general requirements, where you can see an EPL, MA, MB, GA, GB, GC, DA, DB, DC, means that the classification of equipment according to the probability to be an ignition risk is classified in 3 classes, in class A, B, and C. And this means that category 3, here, equipment category 3, you can see, then you can use it in zone 2 or in zone 22 in this case. Zone 2, GG, 3G, GC. It's so confusing, and so it's always very hard for our expert in the field to follow this decoding system coming from the marking of the equipment to the necessary safety level which you need, because the only what you know in the field, I have zone 0, I have zone 1, I have zone 2 from the zone plan. In my zone plan, I can see these 3 classes of zones. Or if it's a dust hazard, then zone 20, zone 21, and zone 22. And I think this is what I want to show you. And here you can see also, again, it's really very specific to learn about this marking system. Okay, I think for now, I am happy to say thank you for listening. Hopefully you could take away something home. And but as soon as you need more assistance, Tolga Bey and Tuyak, and so we are always happy to help you. And if you send email, don't worry. It's not always you don't get invoice immediately after I am answering an email. And so whatever you need as assistance, I would be happy to help you. Thank you for listening.
Biz de teşekkür ederiz Profesör Uwe Klasmayer. Detaylı sunumunuz ve gerçekten bilgi dolu bir içerik için. Tabii süremiz kısıtlıydı. Aslında buradan da belki bu webinarın devamı niteliğinde bir çalışmayı daha beraber ortaya çıkarabiliriz diye düşünüyorum. Sorularınızı soru cevap kısmından iletebilirsiniz ya da sohbet kısmından da. Ben aslında merak ettiğim bir şeyle başlamak istiyorum. İlk soruyu ben sormak istiyorum değerli konuşmacımıza. Genellikle patlamadan korunma daha çok operasyonel, yani işletme aşamasında dokümantasyonlarla daha fazla haşır neşir olunuyor, daha fazla dikkate alınıyorken tasarım aşamasında bu proses emniyeti, proses güvenliği, patlamadan korunma gibi konular nasıl ele alınıyor? Özellikle hani Almanya'daki tecrübelerinizden, uluslararası projelerdeki çalışmalarınızdan ben sizin yorumlarınızı merak ediyorum bu konuda. İlk yatırımcı bu konuyu nasıl dikkate almalı ve tasarım aşamasında nasıl bir çalışma prensibi ön plana tutmalı? Uwe, benim sesim geliyor mu?
I'm sorry?
Sesimi duyabildiniz mi? Sanırım Uwe'nin bağlantısında bir problem var. Sesimi duyabiliyor musunuz? Vedubox'taki arkadaşlar yardımcı olabilir misiniz acaba? Sanırım Uwe'nin bağlantısında bir problem var. Sorumu duyabildiniz mi?
Yeah. I can hear Tolga Bey.
Merhaba. İlk soruyu ben sorayım. Şu anda bağlantıda bir problem yok herhalde. Duyabiliyorsunuz sesimi.
So, are you asking me? I'm sorry.
Yes, Uwe. I'm repeat again the question for you. First, I would like to start with my question to you before their participants' questions. I would like to ask the design process of the process safety or explosion protection.
You mean the risk assessment?
Yes.
The risk assessment. Yeah. So the risk assessment in detail, it starts everything with the materials which you have in your factory to be expected. So let's give an example. You have acetone. So you have some process in your factory which needs acetone as a solvent. Then you have to get awareness about the hazardous material acetone. So you go in the database, which is bringing you the lower explosion limit, upper explosion limit, the evaporation constant of the material. And then you have to say, I need this material in my process. I have to pump it, and maybe some acetone will get in the air, evaporated, and this is another very serious situation, maybe the worker can spill something on the ground. And so this, you have to see this situation, to analyze this situation, and then you have to say, okay, this step in my production process, I only can deal outside. I cannot go with this production step inside, because there is a building around, and this building can accumulate, you can accumulate the vapor air mixture, and immediately you will find also an ignition source. So what you have to decide now is to say, I will go outside, I have a roof, but the roof has no walls. So in case of rain and snow, the worker is protected. And then you can say there is some windy location on my factory area. And so therefore I made everything to get such an evaporated air acetone mixture immediately ventilated away. And this is where you can say, okay, then I say it could be zone 2, less hazardous to make this process, because I made the ventilation around. And there is a new system which is called zone 2 negligible extent. And so maybe there's no need to install X equipment as lightings and so on. So example how the risk assessment is made. Well, everything starts with the material.
Thank you for your answer. And also please turn on the translation right side of the bottom in English. And also there are several questions in the Q&A session. And I will questions in Turkish. Sedat Bey'in bir sorusu var. Can you hear the
Yes.
translation, Uwe? Can you hear the
Yes,
translation?
I can hear you.
Yeah, okay. Sedat Bey'in bir sorusu var. Ben onu ileterek devam edeyim. Bir gemi yakıt tankı deposunda 100 ton gibi F-76 veya F-77 ağır yakıt bulunuyorsa ve bu tank üzerinde manhol yakınında ısıl işlem yapma zorunluluğu oluştuysa, tankı boşaltıp gaz free işlemi uygulanması ile ilgili zaman ve ortam yoksa hangi önlemleri sırasıyla alarak riski minimize edecek işlemleri yapabiliriz?
Yeah, that's really a difficult situation. I think you have to clean the tank, and I can see this here in Turkish also. Sedat has made this. Sedat Bey had made this question. I have to say I need a little bit more time to answer it. I have it here, and I will translate this also what he has written. I could send. See.
Uwe, you can use the translation.
Yeah, in der Nähe, it's in the close to the it's close to the manhole of this tank. I would say, not to make now the wrong decision, I would say I need some kind of sketch and a little bit more information about it, because I cannot answer this question without more information. Maybe Sedat Bey, he can send a little bit a sketch or something like that. You have my email address, Sedat Bey, and I will answer you consistently on this request, because I'm a little bit confused about the question. Keine Lehre der Diagnose, Anwendung der Gasweine. Können wir treffen, um das Risiko zu minimieren? Yeah, ventilation. You have to clean it under heat. Yeah. That's not. I have to say that's not really an easy question. And so the process, I would be very happy to get more information about it. And therefore, Sedat Bey, if you don't mind, please send me an email and a sketch and more information about the process, what you have to do there.
Sorunuz için teşekkür ederiz Sedat Bey. Daha detaylı bilgi için.
Yes, very interesting question. Thank you.
Soruları yine soru cevap kısmından yazabilirsiniz. Aynı zamanda YouTube'dan gelen sorular da varsa yine burada cevaplamaya çalışalım beraber.
Yep.
Tamamdır. Sedat Bey de teşekkür etmiş. Tamam, biraz bekleyelim varsa sorular.
Okay. He will contact to me and he is answering. Çok teşekkür ederim. Okay. Excellent. I'm very happy.
Evet. Tamamdır. Yani süremizi de aslında dolu dolu kullanmış olduk. Tam 1,5 saatlik bir süre kullanmış olduk. Bakıyorum kapatmadan var mı soru diye. Tekrardan. Aziz Bey'in bir sorusu var. Ambalajlı ürünlerin depolanması ile ilgili dikkat edilmesi gereken nelerdir?
What you need to make sure that an evaporation or a leakage of the material what you are storing is possible. So you have to be aware, and you have to make some kind of investigation. Is it possible that combustible material which comes out from this stored containments, which could be IBC, gas bottles or whatever, is there a leakage? And if there is a leakage, is it an amount which can form an explosive atmosphere? This is the exercise you have to do. So as soon as it's a combustible material, which is gas or liquid, then you have to answer these questions. And finally, you have to decide, it could happen that material can come out from these containments. Then you need to organize some kind of ventilation, or you have to put a gas sensor in this room. As soon as you go outside and there is no wall around and it cannot accumulate under a roof, okay, this is also a solution. So but first of all, you have to answer the question, is it possible that an explosive atmosphere from an ignitable amount can be formed? This should be the answer.
Teşekkür ederiz Aziz Bey'e de sorusu için. Tamamdır o zaman. Tüm katılımcılara vakit ayırdıkları için teşekkürler. Umarım güzel bir webinar geçmiştir hepiniz için. Bir sonraki webinarımızda görüşmek dileğiyle diyeyim ben. Ve son sözü Uwe Klasmayer'e bırakayım. Eklemek istediğiniz bir şey, söylemek istediğiniz bir şey var mı sizlerin?
Yeah, I'm just happy that we have attracted participants in this webinar. And so I'm always happy to deal with especially with young people, that we can give some information to them to help them for their daily problems they have to solve. And so this is why we are so happy to give also trainings and so on. But be aware, we also can help you in some kind of help desk also. And that is what my main message to the participants is. Please go in contact, and then we will try to help you. And don't stay at home and try to solve it by a Google research. Don't do that. And so we are always happy to make this. And this is what I want to give also as a message to the participants.
Teşekkür ederiz mesajınız için de. Umarım yüz yüze görüşeceğimiz günleri de tekrardan rahat bir şekilde pandemi sonrasında o eski günlere kavuşuruz diyelim. Hepinize
I have to say I'm sorry to interrupt you, but I have to. For me, it's not normal to be in a meeting room, which is a virtual meeting room. I need the persons to see, and so this is always much more efficient to talk directly to the people than by this tool, this online tool. This is so. I hope so much that at next time we can meet face to face, and to have such a seminar or a conference or whatever, and so we can talk to another face to face. This is what I'm dreaming of.
Bunun için de aslında en yakın etkinlik Mart'ın sonunda gerçekleşecek TÜYAK Sempozyumu yüz yüze. Umarım orada da tekrardan beraber oluruz hep birlikte.
Yes.
Herkese iyi günler diliyorum. Oturumumuzu kapatabiliriz.
Thank you for giving me the opportunity.
Thanks from my side, Uwe.
Okay. Enjoy.
Bye.
Bye bye. Bye.
Bye.